we're talking about graphing and translating square root functions. So first off, we're going to talk about what a square root function looks like, and then we can talk about moving it around, flipping it around, and stuff like that. And we're going to be using A, H, and K, stuff you already know about. But let's talk about what a square root function is. So this right here, f of x equals the square root of x, that is my parent function. That's our starting point. Okay? You can also write it as y equals the square root of x, but I want you to think. If I were to plug x's in for that x there, if I were to plug 0 in, the square root of 0 is 0. If I were to plug in 1, the square root of 1 is 1. And if I were to plug in 4, the square root of 4 is 2. And that's what creates these points over here, where we have a point at 0, 0, a point at 1, 1, and a point at 4, 2. But I want you to see this as well. What if I plugged in a negative 1 there? Well, if you were to plug in y equals the square root of x in your calculator and look at the table, you would get something similar to this table where all of your negative numbers would give you an error message. And I want you to remember why. Whenever you take the square root of a negative, you actually get an imaginary number, right? So that imaginary number isn't going to show up on our graph right here. So that's why my graph looks like this. And so my graph stops. It doesn't go all the way to the left, and it doesn't go all the way down. And that has an effect on my domain and range as well. We're used to saying that my domain is all real numbers, but for this one, my domain, we actually have to find the domain. We actually have to find the range. So how do we move around my graph? Well, you already know a lot of this. You certainly remember that your A controls if you have a vertical stretch or compress, right? That's your A. If you have a negative out in front, if we have a negative out in front of my equation, that's a vertical reflection. Now, with this graph in particular, it's important to remember what a vertical reflection is versus what a horizontal reflection is. So, for instance, if my normal graph looks like that, a vertical reflection would have it flip under like that. Okay, but what about if I have a B? That's right, we are learning about B today because B actually has a big effect on my graph. So I want you to remember a few things about B. First off, your B is backwards, okay? Your B is backwards. What do I mean by that? Well, take a look at this. If you have a 3 on the inside of your square root, that 3 is hanging out with the x. It's on the inside, but it's not adding and subtracting to the x. It is attached to that x. And so it has a very vital effect to it. It's being multiplied, so it's going to cause a stretch or compress. But like I said, B is backwards. So if B is a 3 in here, we're going to have a horizontal compress by 1/3. See how it's backwards? Where originally, with my A, if I had a 4 on the outside, that's a vertical stretch. No, this one's backwards. If I have a 3 on the inside, it's a horizontal compress by 1/3. And if I have a fraction on the inside, it's a horizontal stretch by 2. So that's something new that we're learning about, is B is backwards, okay? B is on the inside, hanging out with your x, and it's attached to it. So just like H is a liar, B is backwards. Okay, so let's talk about our horizontal reflection now. So B also can be negative. So if you have a negative B, if you have a negative B in here, so you have a negative on the inside, so if you have a negative B, that is a horizontal reflection. Now, what does a horizontal reflection look like? Well, we're used to having a normal graph like this, right? Well, a horizontal reflection would take my graph and send it the other direction, like that. Okay? So a vertical reflection flips it from here to here. A horizontal reflection flips it from here to here. Okay? So it turns it like that. Now let's talk about what we already know. We have our H and our K. So remember, your H is on the inside, and your H is a liar, right? My H is a liar. So if my H is -4, we're going to go 4 units to the right. If my H is +3, we're going to go 3 units to the left. So Anything that's inside the square root, anything that's hanging out with the x is a liar. Okay, but on the outside here we have my k. And your k just tells us are up or down. So if we have a 2 on the outside, 2 units up. If we have -5 on the outside, 5 units down. So let's put this into practice on some of these. Let's take a look at 1, 2, 3, and 4 here. So number 1, if I go shift unit 3 units left, that's going to tell me that my h is -3. And then if I have a vertical shift 6 units down, that means my k is -6. Now you have to remember that our original equation, our equation that we're going to be using for this is y equals a times the square root of bx minus h plus k. Now if you notice, I don't have an a or a b on this problem, and so I'm just going to plug in my h and my k. But remember, whenever we plug in my h, it is a liar. So we're going to have y equals the square root of x plus 3 minus 6. And that's going to be my new equation. So since I didn't have an a or a b, I just kind of ignored those. All right, let's take a look at number 2 here. So if we have a horizontal reflection, okay, horizontal reflection, that means I have a -b, meaning I have a negative inside the square root. Okay, and then if we have a vertical stretch by 3, that means my a is 3. So let's write out this equation. It's going to be y equals 3 times the square root of -x. Notice here, I don't have an h or a k. I don't have to worry about them. And so we have a negative on the inside because we have a -b, 3 on the outside. There is my equation. All right, number 3, vertical compress by a factor of 1/2. Vertical compress by a factor of 1/2. That means that my a is 1/2. And then we're going to shift 3 units right. So that means my h is 3. And we're going to go 2 units up. So my k is 2. Okay? So my equation is going to be y equals 1/2 times the square root of, I don't have a b, so we're just going to go x minus 3, and then on the outside here, we'll have a plus 2. All right, our last one, reflect vertically. That means I have a negative in front of my a horizontal stretch by 2. Now, this is where it gets trippy. Horizontal stretch by a factor of 2. So, we're going to have to flip that around. That actually means that my b is 1/2, because remember, your b is backwards. All right? So since we're stretching, we actually have a fraction. Okay? And then a vertical shift down 5. That just means that my k is -5. So if I write my equation for this one, we're going to get y equals a negative out in front because we have a negative a. Then we're going to have 1/2 x on the inside. I don't need quite this big of a square root. Okay, and then we'll have a -5 out on the end. So on this one, notice how I'm missing an h. So you're usually going to be missing 1, maybe 2, all right, as you're putting these equations together. So just be thinking about where each piece is and how that informs your equation, okay? All right, let's go ahead and turn the page, and let's take a look now at actually graphing. Okay, so if you look at number 5 says find all the information in graph. So first off, my a is going to be -1/2. My b is just, well, there's really not a b there, but we say b is 1. My h is going to be +1, because remember, h is a liar. And then my k is going to be +4. So let's talk about some transformations. Let's start with my a. So my first transformation, since I have a negative in front, we're going to have a vertical reflection. Now, it's important that you write vertical this time because it tells you if my graph flips like this or if my graph flips like this. So a vertical reflection means that we're going to flip like this. And so we're still going to be going out to the right. We're just going to be going down like that. All right, so, and then my transformations. My h is 1, so we're going to go to, oh, sorry, forgot about the other part of my 1/2. So since we have that 1/2, that means we're going to have a vertical shrink or compress by 1/2. Okay, so a vertical shrink by 1/2. Then, since my h is 1, we're going to go to the right 1. And since my k is 4, we're going to go up 4. Now, that should tell you where your vertex is. Remember that your vertex is always where your h and k are. Okay? Your vertex is always just whatever your h and k is. And since I went to the right 1 and up 4, we're going to have a vertex right up here at 1, 4. Okay? Since I have a vertical reflection, I know that my graph is going to go out kind of like that. All right? But I want to get some exact points to figure out where that graph is. So to figure out where this graph is, I'm going to show you how to use the table. Now, actually, guys, this table can be used for any of your graphs that we've done. But we're going to use this table to figure out some exact points here. So what we do is we take our parent points and we put them into these new, we go 1 over bx plus h, and that gives you your new x's. We go a times y plus k, that gives you your new y's. So since my b is 1, we're going to go 1 over 1x. But 1 over 1 is just 1, so we're going to go 1x plus h. Well, my h is 1, so we're going to go plus 1. So we're just going to be adding 1 to each of my x's. So 0 plus 1 is 1. 1 plus 1 is 2. 4 plus 1 is 5. So those are my new x's. What about my new y's? Let's take a look at these guys. This one's a bit more complicated. So we're going to go a times y, so that's going to be negative 1/2 times each of my y's plus my k, so plus 4. Okay, so let's start with our first one. Let's start with 0. All right, negative 1/2 times 0 is 0. 0 plus 4 is 4. Hey, I already knew that I had that point. That was my vertex. We still have that vertex at 1, 4. Okay, what about my next point? If I plug 1 in, 1 times negative 1/2 is, oh my, negative 1/2. Negative 1/2 plus 4 is going to be 3.5. Okay, and then our last one, let's plug in 2. Negative 1/2 times 2 is negative 1. Negative 1 plus 4 is, you guessed it, it's going to be 3. So you can see here that we're going to have a point at 1, 4. We're going to have a point at 2, 3.5. And we're going to have a point at 5, 3. So there's 5, 3. And so you can see where my graph is going to go. It's going to go out like that. So notice, instead of my graph opening like this, it flips under, okay? It flips under because we have that vertical reflection. And notice how it's kind of shrinked a little bit, all right, than that graph we did on the first page. Okay, well now let's talk about the domain and range. So for our domain today, we actually have to be thoughtful about where it's going. So remember, your domain is your left and your right, and it's your x value. So my graph doesn't go all the way to the left. It stops right here, and then it goes to the right from there. So my domain is going to be from 1 to infinity. So my domain is going to be x is greater than or equal to 1 or 1 to infinity. But then what about my range? Well, my range is my up and down, right? And on my up and down for this graph, the highest point that I go is 4. But then it goes down from there. Technically, it's going to keep going down for forever. It doesn't go up any higher than that. So my range is going to be y is less than or equal to 4, or, oops, wrote this backwards, or negative infinity to 4, because it goes down for forever. That's negative infinity, so we go negative infinity to 4. Okay? All right. Let's try a couple more here. So number 6, we're going to try my transformations here. So we have the square root of negative 4x plus 16 minus 3. So first off, my a. Well, we have no a for this one, so we just have an a of 1. However, take a look at your b. Your B is really trippy on this one. My B is going to be -4. Okay? So my B is -4. My H is going to be -16 because it's a liar. And my K is going to be -3. Okay? Okay, so let's think this guy through here. So, oh no. Okay. Yep. Okay. Well, actually, guys, I have to, my K, my H, and my B are actually a little bit messy here. Okay? So, my H, since my B is -4, I actually need to pull that -4 out, and we're going to get -4 times x plus 4. So just trust me on this one. You're not really going to see one like this on your skill builder, but your H is just going to be -4. Okay, so we're going to have an H of -4. Okay, forgot to put those parentheses in. So there we go. So we're going to have an H of -4. All right, now my transformations. A is not going to give me any transformations, but B is. So first off, since it's negative, that means we're going to have a horizontal reflection. Okay? And then, since it's 4, that means, remember, B is backwards. So since it's a +4, that means we're going to have a horizontal shrink by 1/4. Okay? All right, and then my H is -3, so we're going to go to the, -4, so we're going to go to the left 4. And my K is -3, so we're going to go down 3. So that tells me where my vertex is. My vertex is going to be at -4, -3, because that's what my H and K is. And so we can see that on my graph here. -4, -3. Okay? Now, which direction is my graph going to go? Which direction is my graph going to go? Okay, so it's going to go out to the left. So I know that my graph is going to look something like that because it's going to go out that direction. But where exactly is it going to go when it goes out that direction? Well, I can find some points to help me figure that out. Okay, so I'm going to take those points and I'm going to plug them into my T-chart here. All right, so let's see here. On the left side of my T-chart, I'm going to have where my B is -4, so we're going to have 1/-4 times x minus 4, and that's what we're going to plug these guys into. And then over here, okay, actually, fellas, I made a mistake here. So whenever I factored out this -4, I should have left it as a negative on the inside here. Okay, so we factor out a negative, and it changes it to x minus 4. And so what that's going to do is that's going to change my vertex to 4/3. Okay, so instead of going to the left 4, we'd actually go to the right 4. And we would have a point at 4, -3 right there. So that's going to change this as well right here. That would be to the right 4. Okay? All right, so we're actually going to go -1/4 x plus 4. Okay? All right, and that'll make a big difference. Okay, so if I take those points here, let's see here, -1/4 times 0 is 0, 0 plus 4 is 4. 1 times -1/4 is -1/4. -1/4 plus 4 is going to be 3.75. And then my last one here, if I take 4, multiply by that's -1, -1 plus 4 is 3. So we end up with 4, 3.75, and 3. Okay? Then if I take my 0, 1, and 2, I can plug those guys in. So if I plug 0 in over here, my a is 1, so it's just going to be 1 times y plus my k. My k is minus 3, so we're just going to minus 3 to each one of these. So 0 minus 3 is negative 3. 1 minus 3 is negative 2. 2 minus 3 is going to be negative 3. Okay? So let's go ahead, let's put these guys on my graph here. And so we have a point at 4, negative 3. We're going to have a point at 3.75, negative 2. And then we're going to have a point at 3, negative 3. Okay? Or negative 1. Golly, this problem is getting my goat today, guys. So 3, negative 1. Okay, so now you can see, hopefully, where this graph is going to go. We're going to have our point there, and you can see that my graph is going to go out, up, and to the left. Okay? All right, now my domain and my range here. My domain is going to be all real numbers left of, how far do we go to the right? We go to 4. So my domain is going to be x is less than or equal to 4 or negative infinity to 4 since I go to the left. But my range actually goes up, and we start at negative 3. So my range is going to be y is greater than or equal to negative 3 or brackets negative 3 to infinity. Okay? Okay, now let's go ahead and turn that page. Let's take a look at our number 7 here. So number 7, we have my a, h, and k. My a, my b is going to be 1. My h is going to be negative 4. And my k is going to be negative 2. So we only have 2 transformations. We're just going to go to the left 4. And we're going to go down 2. And then my vertex is going to be at negative 4, negative 2. And we can see that here, negative 4, negative 2. And then we're going to have my, here, we're going to just add my h to each one. So on each one of these, we're going to go 1 times x minus 4. So that'll be negative 4, negative 3, and 0. And for my k, we're going to minus 2. So we'll be at negative 2. Hey, there's my vertex. And then 1 minus 2 is negative 1. 2 minus 2 is 0. So we're going to have a point at negative 3, negative 1, and a point at 0. And you can see where my graph goes. Okay? So my domain is going to be x is greater than or equal to negative 4 or negative 4 to infinity. And my range is going to be y is greater than or equal to negative 2 or negative 2 to infinity. Okay? All right, let's take a look at these last 2 problems. For these problems, you just need to take a look and see what's going on with our graph. So first off, some transformations. We're going to go to the left 2 and down 1. Okay? Left 2, down 1. Then we have a vertical reflection. A vertical reflection and a vertical stretch by 2. All right, so what does that tell me we have? Well, that means we have a negative a, and that tells me that my a equals 2. Now, how do I know I have a stretch by 2? Well, take a look at this guy. Do you see how it goes down 2 over 1 instead of just going out to that point? It actually goes down 2 over 1 to that point, so that's how I don't have a vertical stretch by 2. And since we go to the left 2, that means my h is negative 2, and my k is going to be negative 1. So my equation is going to look like this. It's going to be y equals the square root of, negative 2 times the square root of x plus 2, and then minus 1 on the end. So there's my equation. Okay? Okay, over here, my transformations is I don't go left or right for my vertex, but I do go down 3 for my vertex. So we're going to have, we're going to go down 3. So that means my k is negative 3. And then we're going to go have a horizontal reflection. So we're going to go to the left. So that means we have a horizontal reflection. That means that my b is negative. Okay? So my equation is going to look like this. We're going to go y equals the square root of negative x minus 3. Okay? And there we go. All right, so that middle question was a bit problematic, but I don't want you to panic about any of this. It really is a lot simpler than it looks. If you have any questions, as always, be sure to let me know, and everything is on Canvas there for you. All right, hope you have a great rest of your day. Thanks, guys.